Hello everyone. In this session we will discuss about rotor efficiency of the three-phase induction motor. Here name itself you know the rotor efficiency, general efficiency is, I will write like this. The rotor efficiency is generally, what is the formula for the efficiency? Output by input. Here the rotor output by rotor input. Rotor output by rotor input, or we can name it as, what is rotor input? Generally you know that the rotor output and rotor input, I can write like this also, that is the output of rotor by, we can name it as the air gap power also, air gap power, because here air gap power and the rotor input both are same, both are same. So in the last discussion we already find out a relation, that is the relation is like this. The relation is, here the rotor input, rotor loss, the rotor output will be like this, 1 is S is 1 minus S. Here this is the rotor input and this is the rotor output. So I will directly write from that ratio, rotor output by rotor input is like this, that is 1 minus S by 1, 1 minus S by 1. So therefore finally the rotor efficiency is like this, that is rotor output by rotor input. So we have some relation. The relation is the speed of the induction motor equal ns into 1 minus S. Here we can write 1 by S minus 1 value is nr by ns. So I will write like this, the nr by ns. Here nr is the rotor speed, here ns is the synchronous speed. nr is, you know, the rotor speed or induction motor speed, generally induction motor speed. This is the synchronous speed of the flux. Flux is only consisting of the synchronous speed. So that's why this is nothing but the 1 minus S. This is a very important ratio. It will be useful. Simply the rotor efficiency can be defined as, it is the ratio of the rotor, this is generally the rotor output by rotor input. Generally the rotor output is considered as the rotor speed, that is the nr, and the rotor input is considered as the ns. This is the one of the important ratio. Here we can tell that it can be observed that the rotor efficiency, here the rotor efficiency is independent on the rotor speed, is depend on the rotor speed. Look at here, the rotor efficiency, it will depend on the rotor speed. So we can write that point, the rotor efficiency is depend on rotor speed, and the speed will be decreases, it will be decreases with increase in slip. If the slip is increases, it will be decreases. How? Look at here, if the slip is increases, here just increases, the what happen, the efficiency will be decreases. So that is the thing. So the rotor efficiency will be decreases with the increase in the slip. Okay, as a result overall efficiency of the rotor decreases. So to maintain the efficiency of the motor, the induction motor is designed to have operating slip in the range of 2% to 8%. So to maintain efficiency, the only thing is the efficiency. To maintain efficiency, the induction motors are designed to the operating slip means that should be operating slip of the induction motor, that value from 2% to 3%, 2% to 8%. So always slip is 2% to 8% What is the reason? The reason is to maintain the efficiency. The operating slip should be 2% to 8%. So this is the rotor efficiency formula, and why the rotor efficiency is always between 2% to 8%. The reason is to maintain the efficiency. Okay. Next, we should discuss now how the power will be distributed in the induction motor. So for that purpose, so generally the electrical, what is the condition, what any motor, the three phase induction motor, the general working is it will take the electrical input and it will give the mechanical output. So it will take input and it will take the output. So that input is entered into the given input will be entered into three phase supply, that is the stator. Three phase supply, this is the stator. That's why the supply complete will be given to the three phase induction motor, and from the three phase induction motor the power can be distributed into two things. One is stator has some loss. It has stator losses. From that power will be given to the rotor. That power will be given to the rotor. Induction motor rotor. That will be given to the rotor. And stator has losses. Generally, stator is two types of losses. Those are stator copper losses and the iron losses. Those are the stator copper losses and the stator iron losses. You know, wherever the winding is available, winding designed with the copper, that's why it consisting of the copper loss, and the winding itself gives the flux. Wherever the flux is there, the flux consisting of the loss, that loss is called as iron losses, because it consisting of the core is there. That's why core losses are iron losses, right? So after getting the power into the induction rotor, again induction motor rotor also have some losses. It has again rotor losses. So after that, gross mechanical power is developed. Rotor will have some losses, and after that the gross mechanical power is developed. Okay, here rotor losses are two types. One is rotor copper loss, again rotor copper loss, and we have rotor iron loss. But iron loss is negligible because slip into frequency. Slip is very less, so rotor iron losses or copper losses are negligible. So the gross mechanical power developed is nothing but the mechanical power. So we are giving the input is the electrical input. So this is the input actually we are giving. Finally that power will be converted as the output here. So this is it will become as the output power. Okay. So that's why we can give the conclusion, that is this is the most important conclusion, that is at starting we can give one conclusion, that is at starting rotor frequency is nothing but the stator frequency. So you should consider, so core losses are considered, generally core losses are available, or you should consider that losses, but at running condition, the rotor have frequency equal to slip times of stator frequency. Then slip is low, so the core losses are negligible. Core losses are negligible. So that's why it's a very important thing. And we can finally give this gross mechanical power developed is there. The gross mechanical power developed, from that gross mechanical power developed, we should remove the rotor windage losses. rotor windage losses, then we will get the net power or complete mechanical power. We should don't forget this loss. We have the this loss also. So this is the distribution of the power. Distribution of the power. So startingly input power is like this, then the power can be converted, finally it will reach to the mechanical power. Mechanical power. So this is about the rotor efficiency and the overall induction motor efficiency. The overall induction motor efficiency. So efficiency of three-phase induction motor is, you know that the rotor output by finally induction rotor output by, or we can name it as stator input, we can into 100 we will get the overall efficiency, or output of three-phase induction motor by, we can write the input of three-phase induction motor, that will give the overall efficiency. So we will discuss about the efficiency very clearly. Okay, I hope all of you understand this session. Thank you.